Hello students, welcome to this new video of digital electronics. Right, this video we are going to see reduction of logical expressions using boolean algebra. Now in this video what we are going to do is reduce the given logical expression. What will be the logical expression? The logical expression is in the form of a complement plus b complement, or a plus b, a or b, something like that, which will be represented to you. That expression will be reduced to some small expression whose output by truth table you can verify it will be correct, and it will be same as the output of the truth table which is given to you in the question. So therefore the output or the truth table of the given logical expression will be equivalent to the truth table of the reduced logical expression. Here in this video we are not going to check it or verify it with the help of truth table. That is your exercise. You can do that with the help of your information about the truth tables logic. So therefore your duty is to do what you need to do, and that verify the truth table, right? And with the help of truth table and that information verify the truth table and write the equivalence of those two, right? So let us start the session with the examples directly, right? So first of all, identify what is Boolean algebra, and then we'll start with the examples. The Boolean algebra, the original word is Boole. Boole was the name of the scientist who started using the algebra in the realization of electronic circuits. That is, in digital electronics, the application of algebra was started using by Boole. So therefore the name of the algebra is given to is a Boolean algebra. So it's a basically branch of mathematics which is used to analyze and simplify logic circuits. The logic circuits like AND logic, OR logic, NOT logic. So in a circuit, if there are number of different types of logic gates are involved, then all those logic gates are not going to be used, but there's simplified version going to be used. The basic operation which is expected as the output is going to be created with the help of Boolean algebra. So therefore it's a branch of mathematics ultimately, right? Because ultimately it involves the mathematics of binary numbers, that is ones and zeros. So therefore it uses only two numbers, binary numbers. Those are called as binary. Binary means bi stands for two, and the two numbers are involved, therefore the name is given as binary. So binary numbers, what are those numbers? 0 and 1. Only two states are available or possible in digital electronics, so therefore those two states are represented by the numbers 0 and 1. So therefore the names are given to bi, that is binary means 2. So binary numbers it is going to use for algebra purpose. In the algebra, there are obviously variables will be involved. In our normal mathematical algebra, we have already identified the variable names as normally assume this is x, this is y, or this is p, this is q. Same way, in the case of binary algebra, the variables are called as binary variables, which are normally or which are capital letters like a, b, c, x, y, z, p, q, r, like this, etc. So remember guys, capital A in digital electronics means it is going to represent a binary variable which can have two states, 0 or 1. Now the rules are there which are going to govern this binary algebra. What are those rules? We have already studied these rules in the case of logic gates, but now they will be used as a rules. What are those rules? Variable can have only two values, 0 or 1, no other than 0 or 1. That is, there won't be 1.5, 1.7, 2.99, 11, 12, like that. Only two numbers are possible in the world of digital electronics, 0 and 1, right? Then complement of a variable a is represented by a complement like this. This is the notation we use to represent the output of NOT gate, right? So which we called it as a negation or a complement. So complement of a variable a is represented as a complement. ORing of the variable a and b is represented as a plus b, which plus means it's a mathematical and not a mathematical addition, it's a logical addition, and logical addition is represented by the operation logic OR. So ORing of the two variables a and b is represented by a plus b, and since there is a OR operation, so there will be AND operation. So AND of the two variables a and b is represented by a dot b or simply ab also. In some cases, in some problems, you'll realize that there is no mention of dot between the two variables. So remember, I am talking about binary variables. So there is no mention of the dot between the two variables like here. So in that case, you have to remember that it's a binary multiplication, or we called it as a AND operation between the two variables. So AND operation will be represented by a dot b or simply ab. You just have to remember it's a ab means it's actually a dot b. So by taking a look at all these rules, now we'll try to solve few problems related to the rules and the related to this boolean algebra. So let us see. Before going that, the rules, yes, right? I was talking about the rules, or we called it as a law. These are the laws that you need to remember always. A dot 0 is equal to 0. Why? Because as I have already told you, the dot means it is representing logic and AND operation says that if any input is low, all and then output, which is single output, will be low. So therefore this law is called as annulment law. That is, a dot 0 is equal to 0 and a plus 1 is equal to 1. What in by that? It's a OR operation. So therefore, if any input is high, output is high. So therefore, a plus 1 is equal to 1. Then a dot 1 is equal to a. A can have two states, right? 0 or 1. So if you consider a is equal to 0 or a is equal to 1, then it is not going to make any changes or any kind of variations, right? So for example, if you consider here, let us identify. If you consider a is equal to 0, then what will happen? A dot 0, right? 0 dot 1. Here we have identified a is equal to 0. So a 0 dot 1, you have already known that it's an AND gate logic says that 0 dot 1 is always 0. So whatever a that I have assumed is getting at the output, it's a a. Similarly, if I assume a is equal to 1, see what will happen. Then it will be 1 dot 1, and 1 dot 1 you already studied that it is equal to 1. So here I have assumed a and I am getting a back at the output, right? So therefore this is called as identity law. So whatever the state of a, that is 0 or 1, if it is ANDed with 1, output will be a. Similarly, if a is added by 0, then you are going to get always a a. This is called as identity law. Then there is a idempotent law, right? So idempotent law is that a will be ANDed with a and a will be ORed with a. In both cases, output will be, right? In both cases, output will be a only, right? Next, now a's operation with its complement, which is called as complement law. So here, if a dot a complement, that is a and a complement, if they are ANDed, then the output is 0. Why? Because see again, if I consider a is equal to 0, a is equal to 0, then its complement will be 1. So 0 and 1, output will be obviously 0. And if you consider a is equal to 1, then a and its complement will be 0. Then a dot 1 dot 0, output will be again in both cases 0. So therefore, in both cases, you are getting 0. So therefore, complement law says that a dot a complement is equal to 0. Similarly, a plus a complement, right? 0 plus 1 always, right? It should be not 0, right? It should be 1. Okay, you note it down properly. A plus a complement is equal to 1. See how? If a is equal to 0, then 0 plus 1, right? 1 is what? Complement of 0, right? Yes. So therefore, you are going to get here 0 plus 1, that is 0 or 1, output is 1. And if you consider a is equal to 1, then A plus 0, right? 0 is what? Complement of 1. So 1 plus 0, it's a OR operation, so therefore output will be 1. So in both cases, you are getting output as a 1 only. So therefore, output is 1, that is, this is a complement law. A commutative law, you know that very well. It's very easy to remember. A dot B is equal to B dot A and A plus B is equal to B plus A. Double complement law. Yes, this is important one. Complement of A is equal to A. This is called as double complement because here again, let us take example. If I consider A is equal to 0, right? Then complement of 0, tell me what will be complement of 0? It will be 1. Then uska complement again, right? Complement of 1, what will be? 0. बराबर है? But what is 1? 1 is what? Complement of 0 only. So therefore you are again going to get 0 back, right? So therefore A का complement and उसका again complement, these two complement operations are going to cancel each other and you are going to get A back. So this rule is called as double complement law. And these are the distributive law, which are, the first law is very easy to remember, easy. A dot B plus C. This is normal multiplication that we used to do in mathematical algebra, normal algebra. That is A into B plus C, that is A dot B. This is the first term, and A dot B dot C, sorry, this will be second term. This is what we used to do in our mathematics. But this is very different one. The second law. A plus B dot C. Remember, in some cases there won't be this dot. It will be simply BC. You just have to remember BC in digital electronics means B dot C. So when A plus B dot C is there, then remember, then take a look at the output. What I have done is A plus B is written down in one bracket C, and the sign between the two is dot, and A plus C. So A is added with B first, then A is added with C second. This is called as distributive law, in which OR logic is distributing first bracket and dot, that is AND logic is distributing second bracket. So between the two there is a dot, here between the two there is a plus sign, which is called as distributive law. So these are the laws basically which we are going to use for solving the Boolean algebra problems, right? So now let us try to go through some problems, some examples, so that the concepts will be pretty clear to you, right? So I'm starting with the first one, right? The law says that, or question says that simplify a complement of A dot B plus C, plus B only, right? So let us try to solve this particular problem. So in this example, right, we are going to see this law again. So therefore what I'm doing is I'm copying all these laws and pasting on this example page. So this is the example. Simplify A dot B ka complement plus B. So this is what kind of question. This is not a question that you will be expecting in the examination. This is a very simple question. Now this question needs to simplify you the given particular Boolean expression. This is a Boolean expression, and this Boolean expression will be simplified with the help of the laws which are written down here. These are all the laws which were you have seen in the previous slide. So these are the laws that we are going to see and use so that this equation can be simplified. Okay, let us see how to simplify it. So the ink I'm using, yes, okay. So the first one is, right, what I am going to do is here I have been given first term as A plus B ka whole complement. Now if you watch it, if you take a look at this carefully, you realize that this is the De Morgan's laws. The De Morgan's laws that you have studied in the slide, in the video of De Morgan's law. And the first one, this is what this term is, right? Complement of A dot B. Now what will be the complement of A dot B? Here it is equivalent to complement of A plus complement of B. So instead of this term, I am going to substitute it by A complement, sorry, plus B complement, right? This is RHS of this first law of De Morgan's first law substitution, right? Plus the last term, which is B, which will left as it is. The rule that I have used here is De Morgan's law. So writing down De Morgan's law. So this is first statement. Now you have three elements present in the Boolean algebra: A complement plus B complement plus B only. Now take a look at these two terms together. Here you can see B complement plus B. Now take a look at the equation where you can find similar type of terms. Yes, these are the terms. Here you can see A plus A complement is equal to 0, right? So if it is in that form, but here you can see A is written first, then A complement written down, and their sum is equal to, or sorry, the OR operation is equal to 0. Now, but here written down as B complement first, then B, right? The terms complement plus term. So what we can do is you can use this commutative law. This is called as commutative law. A plus B can be written as B plus A. So what I'm going to do is I'm writing down this first term A complement as it is, but the second and third term is going to interchange their position. Here I'm going to write down this third term B as first second one, and then this will become third one. So B plus B complement, and now the rule that I am used is commutative law, right? By commutative law. Now this commutative law gives you this expression. Now I can use this substitution A plus A complement for these two terms. This will be replaced by 0. So therefore what I am going to get is A complement plus these two will be replaced by 0. So the rule that I have used is complement law. Okay, so writing it down. So the rule used is complement law. Now you can see A complement plus 0. Which law is going to be used here? Yes, this one. Here you can see that A plus 0 is equal to A. That means if 0 is odd with any of any particular number, any variable, you are going to get A back. So therefore here instead of A, it's a complement. So therefore you are going to get A complement as it is, and the law used here is identity law. This is called as identity law, right? So identity law, and there is no further simplification possible. So therefore you are going to get this as your final result. Okay, so this is what you're going to get. So simplification of complement of A dot B plus B is equal to A complement. Okay guys, right. So let us gear up for the next question. Okay, so let us take a look at next example, right? So in this example, which we have already seen, in this example, you are supposed to simplify this. A dot B dot C is equal to plus A complement plus A dot B complement plus C. Now in this example, you are supposed to simplify. That means you are trying to reduce this bigger equation into smaller Boolean expression. The help will be obviously given by these equations and rules which are present on this side. So let us start with this. First of all, try to analyze and go through the common numbers or factors which we can use somewhere. Here you can see the first term, this first term and third term. Now in this first term and third term, you will realize, right, let me first of all check. Yes, in the first term and third term, you realize it's a dot b dot c, and it is a dot complement of b dot c. That means a and c are common for term number 1 and term number 3. So therefore we can use distributive law in this case, so that we can take common a and c out of the bracket, and inside bracket there will be b and b complement present. The law that is going to be used is this law. This is distributive law, and we are on LHS side of this distributive law, and we will be converting to RHS side of the distributive law, right? So therefore, for that specific case, what we are going to use is distributive law. Let us see how to use that distributive law. Okay, so the term number 1 and 3 taking a and c common. Let us see how. Here I am writing down a dot c common from these two terms. So from first term, if I take a and c common out of the bracket, then inside bracket the term left will be simply b, right? Plus, why plus sign? Because this third term is also having plus sign, that is OR operation. And if you take a and c out of these two, this third term, then third term will be, the only left one will be b complement. And the law here used is distributive law, right? So distributive law, right? So distributive law gives you this output. And here now, if you take a look at the bracket, sorry, one more term was left, right? A complement we have written, we have not written down. The second term will remain as it is, right? So this is second term, that is a complement. So now if you realize b plus b complement, it is in this form, right? Where is b plus b complement? Yes, this is identity law. This is a plus a complement is equal to 0. So same way b plus b complement also will be replaced by 0. So a c as it is, dot, right? If no sign is involved, that means it is dot 0 plus a complement, right? So a plus sorry, it's not 0, sorry, it's not 0, it has to be 1, right? A and complement of a, both, if it has been added, it should be 1, right? Not 0. The mistake that I had done in the previous slide, same mistake is reflected here also. It is not reflected, sorry. A plus a complement is always gives you 1, not 0, right? So it should not be 0, it should be 1. Okay, so a dot c dot a, dot 1, right? This should be the term, right? Let me rewrite it properly. So it should be a dot c dot 1 plus a complement. This is what you're going to get, and the reason for this is identity law. So identity law. Now if you check the law for this, you can see that a dot 1 is equal to a. And why I'm talking about this law? Because a dot c dot a dot 1, sorry. So therefore these two, if ANDed together, you are going to get a dot c back as it is. So therefore here it will be a dot c as it is plus a. Here we have used this particular law, right? So this is called as idempotent law, right? Okay, so idempotent law. Now, next further simplification, if it is possible, let us see. A dot c is plus a complement. Now this is in this format. right? A plus B dot C is equal to A plus B dot A plus C. Now this is distributive law. Here it is in this format, but in the reverse order. So therefore, get the order correct. That is A complement first, sorry, plus A dot C. Sorry. And the law we are going to use is a commutative law, right? Right? So commutative law. So the commutative law gives you this simplification, and distributive law this, right? This law shows that A plus, here instead of A it's a complement. So A complement plus A dot C, here B dot C is equal to A plus B dot A plus C. So therefore this will be added, that is odd with A and odd with C separately. So therefore you are going to get A complement plus A in one bracket dot A complement plus C in second bracket, right? The law which we have used is again distributive law. Okay. Now A complement plus A, here again the same law, that is this law, identity law. So this will be 1 dot A plus this A complement plus C is nothing going to happen. It remains as it is. So A complement plus C. The law which we have used is a identity law. And therefore, right, now the law which we have used, idempotent law. So therefore same is going to used here also. The output will be A complement plus C. The law uses idempotent law. Yes. So ultimately what we have started here is A dot B plus dot C plus complement of A plus A dot complement of B dot C comes down to this final answer. Okay. Let us find the next question. Here A plus B dot A plus C is equal to A plus B dot C. This is what we want to show. This is the law which we have to prove here. See, this is the law. We need to prove this law. How to prove this? We need to use our normal mathematics. If the two terms are there and there between the two terms, if there is a multiplication, we know that how to perform multiplication of two, right, two polynomials. So here A will be multiplying this A will be multiplying this C, B into A, B into C, like that, right? So starting with our LHS, right, we will get RHS. So LHS is A plus B into A plus C, right? Normal algebra. Now A plus, right, here there is a dot means, right, and operation. So A and A this A plus A and C plus B and A plus B and C, right? Here I have used distributive law. Right? So distributive law is used here. Now A dot A. What will be A dot A? Let us see. Yes, A dot A is A only, right? Plus here A dot C plus B dot A also can be written down as A dot B also, right? Barabar hai? A dot B, B dot A, same. Why? Because it's a commutative law. Commutative law says that A dot E, B or B dot A same hota hai. So therefore here A dot B instead of B dot A plus B dot C as it is. There won't be any change. Now, here you can see A plus A dot C. This is the law. A plus A dot C, right? This law says that A plus B dot A plus C. So therefore here A will be added with A and C separately. So I'm writing down their brackets and between them and operation plus A dot B plus B dot C, right? So now you will get A plus A. Answer is A, right? How? This law, A plus A is equal to A dot, now A plus C plus A plus B plus B plus C. The two terms remains as it is. They will be added. Then A dot A, again we are going to use distributive law. This, right? A dot B plus A. Instead of B there is A. So therefore the outcome will be A dot B. So instead of B it's a only. So A dot A plus A dot C plus A dot B plus B dot C, right? So therefore now A dot A is same thing, right? A dot A, it's same, it's A only, plus, right, A dot C, right? So A dot C will be again added. Sorry, one second. Yes, what has happened here? So here I have made, I think, a mistake. Yes, right. So otherwise we are stuck in the loop. Same numbers we are getting again, A plus A dot C. So here I think this, at this step there should be substitution. The A can be taken common from these two terms and then there will be substitution. Let us first of all, let me erase this. From this step onwards everything must be erased. Right. Yes, this is wrong, everything is wrong. Now let us see what we need to do the second step onwards. Right. Okay. Right, let us start. Let me change the mode. Yes, pen mode. Yeah. Yes, let's start with a new ink also. So here what we need to do is start with LHS and I'm going to apply normal mathematics rule, A plus B multiplying A dot A plus C. So A will be multiplying first bracket, so it will be A into A plus C plus B into A plus C as it is, right? So it's a distributive law. Right? So distributive law going to be used. Then A dot, again distributive law going to be used, A dot A plus A dot C, sorry, plus B dot A plus B dot C, right? So again the distributive law used here. Now A dot A, here I have already told you, is equal to A only. So therefore A dot A replaced by A, right, plus A dot C, plus I am going to replace this B dot A as A dot B by this law. So commutative law. So it will be A dot B plus B dot C. Now here From these two terms, a can be taken common. So if you take a common from these two terms, the first term is left with 1. Why 1? Because a dot 1 is always a. So therefore a can be splitted into two parts as a dot 1. So I am taking common and there will be dot between the two. So therefore this will be 1 plus out of a and c. If a is taken common, left one is c, plus a dot b as it is plus b dot c as it is. Now 1 plus c, here the law, identity law says that a plus 1 is always 1. So therefore these two things whenever added together, you are going to get 1. Whenever added with any variable, it provides you answer as 1 only. So therefore a dot 1 plus second and third term as it is. So now a dot 1, right? A dot 1 is equal to a itself plus a dot b plus b dot c. But now from first term and second term, a can be taken common as we have did in this step, right? Same way a is taken common, so inside the bracket it will be 1, right? Plus second term may say b plus b dot c as it is, and here 1 plus b, as we have used here 1 plus c replaced by 1, so similarly 1 plus b also replaced by 1 only, plus b plus c, which comes down to a into 1 is always a plus b into c, and this is what we want to show, right? Hence shown LHS is equal to RHS, right? So this way the laws of distributive can be used to verify the result which is given to you. Let us try this next question. This entire will be replaced by A, right? So let us try to go through this. So starting with LHS and identify the strategy. First of all, here you will realize that a dot b ka complement. So that means this can be replaced by a complement plus b complement by using the law this, right? So therefore inside bracket it will be a complement plus b complement dot a complement plus b as it is as the second and third bracket a complement plus b, right, as it is, right? So this will be your second and third bracket which are not going to change, right? Then next one, here I think there is a typing mistake. It has to be b bar, not a bar. Let me change it. This is b bar, not a bar. It's a b bar, so therefore let me change. Okay, so this should have been b bar, right? So b bar plus b. Let me change the color again. Yes, lemon yellow. Chalo. So this will be, this is a De Morgan's law substitution. Complement of a dot b substituted as a complement plus b complement, right? So it just substituted as it is, right? So all other terms remains as it is. Now the next term what I'm going to do is replacing these two by 1. How? You can use this law, right? A plus a bar is equal to not 0, guys. This has to be 1, right? So this will be replaced by 1. Then a bar plus b bar dot a bar plus b. So again you realize that there is a dot and these two terms will be multiplied, right? So therefore you can easily get this common out of the two terms and this will be replaced by 1 in the next step. So let us go step by step. First, a bar plus b bar dot a bar plus b, and these two terms will be replaced by 1, right? Their addition, this is a complement law, the addition is equal to 1, and 1 into anything gives you that answer only. So therefore this will be a bar plus b bar dot a bar plus b, and this term, these two bracket terms are quite similar to these two bracket terms. You can see a plus b dot a plus c. Here in both brackets, a is present at the first location, and here a, and here instead of a it's a complement present at the first location, and the next two terms will be b complement and b. Those are immaterial. Important one is first term is same, here first term is same, and between the two there is a plus sign, plus sign, plus sign, plus sign, and dot. So therefore this rule can be used to replace these two brackets by this bracket. Here the common term is written outside, so that means a complement, which is a common to both brackets, has to be written outside. After that there is a plus sign. This is a distributive law I'm talking about, right? Plus sign, and then inside bracket it's a b dot c. What in by b dot c? Here the other two terms of the two brackets. So here the two terms are b complement and b respectively. So therefore writing down those b complement, there is a dot, that is and operation, and b. Now a and a complement is equal to 0, obviously, then b and b complement, not this one, right? It will be complement, not this one. B complement dot b will be obviously equal to 0, so therefore a complement plus this will be replaced by 0, and anything plus 0 is that term again, so therefore you are going to get a complement, right? So therefore this is our RHS, right? So therefore RHS and LHS both has been shown to you. Let us see next question, right? The next question is a plus this is equal to a plus b we want to show. So let us start with LHS first. LHS is a plus complement of a dot b plus a dot b ka complement, right? So therefore now let us see what is going to happen here. If you look carefully, the first term and third term, in the first and third term there is a common. So let us write down these two terms side by side first. So I'm writing down first term a plus third term I'm writing down first a dot b bar plus a bar dot b. This is third term. So writing down these two terms together. Now these two terms can be obviously replaced by some kind of other term. Now let us see what is going to happen. Here you can see a plus a dot b bar, right? So either you can use this terminologies in which a will be added with a plus a will be added with b complement, and in the next step again you can take that b common and you will ultimately get a and b separate out, right? So you can use that term. Let us try that fashion, right? So a plus b dot c, here a plus a dot b bar, right? So therefore it will be, the substitution will be inside bracket a plus b, here a plus b, here b is a itself, so therefore a plus a dot, right, dot a plus, here c is, here it will be b complement, plus last term a complement dot b is as it is. Then next will be a plus a. You can see where is a plus a. A plus a is a only, right? So therefore you are going to get same. I am again stuck in the loop only. Let us forget about this step. I think I need to take a common, right? A and then 1 plus b complement. that step has to be written down as we had did in the previous case. And last term a bar dot b bar as it is, right? So this step is not going to work out. So therefore this, then here a 1 plus b complement, you know that whenever 1 is added to any term, you are going to get 1 as the output only. So therefore here you are going to get what you are going to get. Yes, let me check first of all. Yes, 1, sorry, a plus 1 plus b complement, you are going to get b complement back, right? Plus a complement dot b, right? Right, b complement will be b complement plus 1 will be added when your answer will be, sorry, not b complement, it will be 1, right? So let me erase it. Yes, pen, it will be 1. So you will get 1 plus a complement dot b, right? This 1 into a is going to get a back, so therefore this will be the law. Now these two, there is a or operation and there is an and operation, so now we can use this law. There is nothing common, so therefore now we can use this law where it will be split into two brackets like a plus a complement dot a plus b, right? Here a complement will be b and b will be c actually. So this will be a plus a complement. You know that a plus a complement is not 0, guys. This will be 1. So therefore this is 1 dot a plus b. And 1 dot a plus b is again a plus b, and which is your RHS. So in this way, we can show LHS is equal to RHS, right? Let us try next question. If it is any, yes, the last one I think, a complement dot b complement dot c complement plus, we want to simplify this whole bracket, and you'll realize that before simplification start beginning, you'll realize that question term number 1 and term number 2, the two terms, these two terms are common. So therefore in the first step only you can take a complement dot b complement common from the two terms, then inside the two terms the first will remain as c complement and this will remain as c, right? Second term is a c plus a complement dot b as it is. So this will be now a complement dot b complement. Now what will happen to c complement plus c? C complement plus c will be obviously in this case not 0, guys. This will be 1, right? So this will be 1 plus a complement dot b. Now a complement dot b complement into 1 by law, this remains as same term, sorry, plus a complement dot b. From first two terms, these two terms, a complement can be written down commons, that is distributive law. So a complement inside bracket, first term में से b complement plus second term में से b, and you are now clever enough, b complement plus b can be substituted by 1. So now you are going to get a alone as your final answer, right? So this is how you can simplify the given question, which is with the help of the laws, right? So this is guys final one. So that's it for this video. Here in this video you have seen how the reduction process of given algebraic equation can be done with the help of the rules and the theorems that we have studied in this video, right? Thank you.